Hello everyone, my name is Abilkhayir, and I'm going to introduce you the topic distributed software engineering. Nowadays it's very important approach in software engineering, and let us take a look what topics will be covered. The topics are distributed systems issues, client-server computing, architectural patterns for distributed systems. First of all, I think it will be better if we determine the notion of distributed software engineering. So let us answer the question, what is the distributed software engineering? The distributed software engineering is a branch of software engineering which deals with the study of the collection of independent software systems that appear to the user as a coherent system. To understand more deeply, let us compare distributed systems with centralized systems. So what is centralized system? State stored in a single machine, and it's very simple, easier to understand, can be faster for a single user. What is distributed system? State divided over multiple computers, so more robust, more scalable, and more complex. What are the characteristics of such systems? Resource sharing, it means sharing of hardware and software resources. Openness, use of equipment and software from different vendors. Concurrency, concurrent processing to enhance performance. Scalability, increased throughput by adding new resources. And fault tolerance, the ability to continue in operation after a fault has occurred. What kind of issues is there in distributed systems? Distributed systems are more complex than systems that run on a single processor. Complexity arises because different parts of the system are independently managed, as is the network. There is no single authority in charge of the system, so top-down control is possible. And also we will talk about the design issues. So what kind of issues? Transparency, openness, scalability, security, quality of service, and failure management. And later we will consider each of these design issues separately. What is transparency? Ideally, users should not be aware that a system is distributed and services should be independent of distribution characteristics. In practice, this is simple because parts of the system are independently managed and because of network delays. Often better to make users aware of distribution so that they can cope with problems. To achieve transparency, resources should be abstracted and addressed logically rather than physically. Middleware maps logical to physical resources. The next one is openness. Open distributed systems are systems that are built according to general accepted standards. Components from any supplier can be integrated into the system and can interoperate with the other system components. Openness implies that system components can be independently developed in any programming language, and if this conforms to standards, they will work with other components. Web service standards for service-oriented architectures were developed to be open standards. The next one is scalability. The scalability of a system reflects its ability to deliver a high-quality service as demands on the system increase. And next one is failure management. In a distributed system, it's inevitable that failures will occur, so the system has to be designed to be resilient to these failures. Distributed systems should include mechanisms for discovering if a component of system has failed, should continue to deliver as many services as possible in spite of that failure, and as far as possible automatically recover from the failure. And also we have two types of interaction between components in a distributed system. The first one is procedural interaction, and the second one is message-based interaction. Procedural interaction, where one computer calls on a known service offered by another computer and waits for a response. And second one is message-based interaction. Involves the sending computer sending information about what is required to another computer. There is no necessity to wait for a response. Procedural communication in a distributed system is implemented using remote procedure calls. Here the examples of procedural interaction between a diner and waiter. For example, waiter says to diner, "What would you like?" Diner answers, "Tomato soup please," and so on and so forth. The next one is the example of message-based interaction. So all interaction data is coped in the XML format. So procedural communication in the distributed systems is implemented using remote procedure calls (RPC). In a remote procedure call, one component calls another component as if it was a local procedure or method. The middleware in the system intercepts this call and passes it to a remote component. This carries out the required computation and via the middleware returns the result to the calling component. A problem with RPCs is that the caller and the callee need to be available at the time of the communication, and they must know how to refer to each other. The second way is the message passing. Message-based interaction normally involves one component creating a message that details the services required from another component. Through the system middleware, this is sent to the receiving component. The receiver passes the message, carries out the computations, and creates a message for the sending component with the required results. In a message-based approach, it's not necessary for the sender and the receiver of the message to be aware of each other. They simply communicate with the middleware. So, let us talk about the middleware. What is middleware? The components in a distributed system may be implemented in a different programming language and may execute on completely different types of processors. Models of data, information representation, and protocols for communication may all be different. Middleware is software that can manage these diverse parts and ensure that they can communicate and exchange data. Interaction support, where the middleware coordinates interactions between different components in the system. The middleware provides location transparency in that it isn't necessary for components to know the physical locations of other components. The provision of common services, where the middleware provides reusable implementation of services that may be required by several components in the distributed system. By using these common services, components can easily interoperate and provide user services in a consistent way. So next topic is client-server computing. Distributed systems that are accessed over the internet are normally organized as client-server systems. In a client-server system, the user interacts with a program running on the local computer. This interacts with another program running on a remote computer. The remote computer provides services such as access to web pages which are available to external clients. So here we have some key points. The benefits of distributed systems are that they can be scaled to cope with increasing demand, can continue to provide user services if parts of the system fail, and they enable resources to be shared. Issues to be considered in the design of distributed systems include transparency, openness, scalability, security, quality of services, and failure management. Client-server systems are structured into layers, with a presentation layer implemented on a client computer. Servers provide data management, application, and database services. Client-server systems may have several tiers with different layers of system distributed to different computers. And we're going to talk about architectural patterns, widely used ways of organizing the architecture of distributed systems. The first one is a master-slave architecture. Master-slave architectures are commonly used in real-time systems where there may be separate processors associated with data acquisition from the system's environment, data processing and computation, and actuator management. The master process is usually responsible for computation, coordination, and communications, and it controls the slave processes. Slave processes are dedicated to specific actions such as the acquisition of data from an array of sensors. The next one is two-tier client-server architecture. In the two-tier client-server architecture, the system is implemented as a single logical server plus an indefinite number of clients that use that server. This thin client model, so we have two models, thin client and fat client. Thin client model, where the presentation layer is implemented on the client and all other layers are implemented on a server. Fat client model, where some or all of the application processing is carried out on the client. Data management and database functions are implemented on the server. The next one is the multi-tier client-server architecture. In a multi-tier client-server architecture, the different layers of the system, namely presentation, data management, application processing, and databases, are separate processes that may execute on different processors. This avoids problems with scalability and performance if a thin client two-tier model is chosen, or problems of system management if a fat client model is used. Here the some scheme of distributed component architecture, and we're going to consider peer-to-peer architecture. P2P systems are decentralized systems where computations may be carried out by any node in the network. The overall system is designed to take advantage of the computational power and storage of a large number of networking computers. Most P2P systems have been personal systems, but there is increasing business use of technology. So, in conclusion, I want to say that precisely the distributed software development technique is quite profitable and fast developing among other techniques, and is being adapted in many organizations across the globe. Though it has some concerns regarding security and transparency of the product, but nothing is perfect in this world, I suppose. Thank you very much for attention.